If I dropped you on Mars right now without a suit, you wouldn't last 2 minutes. Not because of aliens. Not because of some Hollywood explosion. You would die quietly, suffocating in a near vacuum, your blood beginning to boil at body temperature, exposed to radiation levels that would terrify any doctor on Earth. And yet, serious scientists and engineers believe humans could live there. So which is it? Instant death or humanity's second home? Let's interrupt the fantasy first. Mars is not a backup Earth. It is brutally hostile. The average surface temperature is about minus 63 degrees Celsius. At night near the poles, it can plunge below minus 125. The atmosphere is more than 95% carbon dioxide, with less than 1% oxygen. The surface air pressure is less than 1% of Earth's, so low that liquid water cannot stably exist for long. And radiation? Mars has no global magnetic field and only a thin atmosphere. According to data from NASA's Curiosity rover, radiation levels on the Martian surface average about 0.67 millisieverts per day. That's roughly 240 millisieverts per year, far higher than the global average background radiation on Earth, which is about 2 to 3 millisieverts per year. Long-term exposure at those levels significantly increases cancer risk. So when people say, we'll just move to Mars, they're skipping over a very uncomfortable truth. Mars is closer to Antarctica than to Arizona, but without breathable air. Now here's the twist. Despite all that, no known law of physics says we can't live there. The real question isn't, is Mars dangerous? It absolutely is. The real question is, can we engineer our way around those dangers? Let's break it down. First, the journey. Mars is not next door. Depending on orbital alignment, it takes about 6 to 9 months to travel there with current propulsion technology. Astronauts would be exposed to microgravity and deep space radiation the entire time. NASA's studies on the International Space Station show that long-duration spaceflight causes muscle atrophy, bone density loss, fluid shifts in the brain, and immune changes. A Mars crew would face these risks for more than a year round trip, even before stepping onto the planet. Pattern interrupt. Even if you survive the trip, landing safely is another nightmare. Mars has just enough atmosphere to create intense heat during entry, but not enough to slow a heavy spacecraft easily with parachutes alone. Landing large payloads, habitats, life support systems, return vehicles remains one of the biggest engineering challenges. NASA's Perseverance rover used a complex sky crane maneuver in 2021, but that rover weighed about 1 metric ton. Human missions will require landing 20 to 40 metric tons or more in a single piece. Now let's say we solve that. You're on the surface. What keeps you alive? Air, water, food, shelter, and radiation protection. Oxygen can theoretically be produced from the Martian atmosphere. In 2021, NASA's Perseverance rover successfully tested MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment. MOXIE converted carbon dioxide into oxygen, producing about 6 grams per hour in its best runs. That's tiny, roughly enough for a small dog to breathe, but it proved the concept works. A scaled-up version could support human habitats. Water is more promising than many people think. Mars has significant water ice, especially near its poles and beneath the surface at mid-latitudes. Radar data and lander observations confirm subsurface ice deposits. Future missions could mine and melt this ice for drinking water, oxygen production, and even rocket fuel through electrolysis. Food is harder. You can't farm Mars soil directly, not without processing it. Martian regolith contains perchlorates, chemical compounds that are toxic to humans. Any agriculture would likely happen in controlled indoor environments, hydroponics or aeroponics, using purified water and carefully managed nutrients. Experiments on Earth have shown plants can grow in simulated Martian soil, but real large-scale food independence would take years of development. Now here comes the controversial part. Some advocates talk about terraforming Mars, transforming it into a warmer, thicker atmosphere planet where humans could walk outside without pressure suits. But according to current scientific understanding, that's not realistic with today's technology. A 2018 NASA-sponsored study concluded that Mars does not have enough accessible carbon dioxide in its polar caps and soil to create a thick, Earth-like atmosphere, even if we released all of it. Terraforming, at least on a planetary scale, would require technology and energy sources far beyond anything we possess. So if humans live on Mars, they will likely live inside pressurized habitats, domes, underground bases, lava tubes. Yes, lava tubes. Orbital imagery suggests Mars has ancient volcanic lava tubes that could provide natural shielding from radiation and micrometeorites. Building habitats inside or beneath the surface could dramatically reduce radiation exposure, solving one of the biggest health threats. But let's interrupt again. Even if we solve the engineering, there's the psychological factor. Mars is, at its closest, about 56 million kilometers away. Communication delays range from 4 to 24 minutes one way, depending on planetary positions. That means no real-time conversations with Earth, no quick rescue missions. If something breaks, you fix it yourself, or you don't survive. Isolation studies on Earth, including Mars simulation habitats in Hawaii and Antarctica, show that small crews in confined environments face stress, interpersonal conflict, sleep disruption, and mood changes. A Mars mission wouldn't last weeks. It would likely last years. So why even try? Because Mars is the most Earth-like planet we know. It has a 24.6-hour day, very close to Earth's 24 hours. It has seasons due to its axial tilt of about 25 degrees. It has water ice. It has the raw ingredients for fuel production. Compared to Venus, with its crushing pressure and 460 degrees Celsius surface temperatures, Mars is the more practical option. And there's a bigger argument that divides experts. Is colonizing Mars a distraction from saving Earth? Some critics argue that investing billions into Mars exploration takes focus away from climate change and global inequality. Others argue the opposite, that space exploration drives technological innovation, international cooperation, and long-term survival strategies for humanity. Here's a hard fact. Earth is still vastly more habitable than Mars, even in worst-case climate scenarios. You could walk outside today almost anywhere on Earth with minimal equipment and survive. On Mars, you need advanced life support every second. So Mars is not an escape plan. It's a long-term experiment in survival. As of 2026, no human has set foot on Mars. NASA's Artemis program aims to return humans to the moon as a stepping stone. SpaceX continues developing Starship, a fully reusable spacecraft designed with Mars missions in mind, though it is still in testing phases. China has also expressed long-term Mars ambitions after successfully landing the Zhurong rover in 2021. But timelines are fluid. Human Mars missions are often discussed for the 2030s or 2040s, depending on funding, technology readiness, and international collaboration. And here's something people don't always consider. The first humans on Mars wouldn't live comfortably. They would live carefully. Every breath measured. Every crop monitored. Every system redundant. It wouldn't look like a science fiction city with glass domes and open plazas. It would look like survival. But survival is how every civilization begins. The first permanent settlers would likely rely heavily on Earth for supplies. True self-sufficiency, producing food, water, oxygen, building materials, and spare parts locally, could take decades. So could humans really live on Mars? Yes, if we build the right systems. No, if we imagine it will feel anything like Earth. Mars will never be easy. It will demand precision, discipline, and constant innovation. But it offers something Earth cannot: a second location for human civilization. A scientific treasure trove that may hold clues about whether life ever existed beyond our planet. And that might be the biggest motivation of all. Because if we find evidence that life once existed on Mars, even microbial life, it would mean life can emerge on more than one world. And that would change everything about how we see our place in the universe. So the real question isn't just whether we can survive on Mars. It's whether we're ready for the responsibility of becoming a multi-planetary species. If this opened your eyes, follow for more deep explorations into humanity's future in space. The next few decades may redefine what it means to call a planet home. Now I want to hear from you. If given the chance, would you spend the rest of your life on Mars knowing you might never return to Earth?